Question 17 says, James can throw a javelin 49 metres. His target is to throw 4% further each year. So that kind of suggests you're going to add things, because we're adding each year. If he stays on target, how many years will it be before he can throw the javelin 55 metres? So it looks like you're going to add things until you get to like 55 metres. So first things first is this one here. So you start with 49 and you times it with 4%. And we get 1.96. And because it's 4% further each year, we add 1.96. And so after the first year, you can throw it at 50.96 metres. So this is like a compound interest question where you're just adding percentages and then adding. Next one, we're just repeating everything. We're just taking the new value, which is 50.96, and we get 4% of that, which is 2.0384, and we add that to the 50.96. We should get 52.9984, which is after 2 years. That's how far he's thrown it after 2 years. And the next part is we get 4% of this new value, which is 2.119936, and we add it to the 52.9984. That becomes 55.118336. So that has gone over the 55 metres. So what that means is it's taken 3 years to actually get to over 55 metres. So for question 18, this is an estimate of the mean question. So that means that we have to get midpoints in fx columns. So we have to add another 2 columns to this. Right, so we have a midpoint column and an fx column. So the f is the frequency and the midpoint is the x. You could easily just put, instead of fx, just put f times midpoint, or frequency times midpoint. So what we want to get is the midpoints first. So to get the midpoints, we can add those 2 numbers at the end of these things. So it'd be 0 and 3. 0 plus 3 is 3, divided by 2 is 1.5. 3 plus 6 is 9, divided by 2 is 4.5. So this gives us the middle part of those numbers. So 1.5, 4.5, 7.5, 10.5 and 13.5. The next thing we do is we multiply the frequency times the midpoint. So we do 18 times 1.5 is 27. 45 times 4.5 is 202.5. So this is what we do on each of those rows. Next thing we do is we get the total of your fx column. So that will be 760.5 when we add all those together. And we get the total of our frequency column, which is, when we add them up, is 123. We take the 760.5 and we divide by the 123. So that should equal 6.18. So the mean for this one would be 6.18 hours. Now a lot of people make a mistake of adding the midpoints and dividing with that. So try and make sure that it's the frequency and the fx column you add up. Okay, so question 19 is a scattergraph question. So it says, Janet sees a scattergraph which displays the age and blood pressure of 10 adults. Janet is aged 41 and her father is 84. She comments that a good estimate for her blood pressure would be 139, whilst a good estimate for her father's would be 156. Do you think her estimates are reliable? Explain your reasoning. So you can see that if you do 41 and you draw a line up and across, it looks decent enough. And if you draw a line here, it actually hits that point. But for her father's, you can see the points stop here. So there's no points after this point here, or this part of the line. So if there was any extra points there, it could affect this best fit line. So it couldn't be reliable. It has to be within those points to make it more reliable. So if we look at that, it says, do you think our estimates are reliable? Explain your reasoning clearly. The estimate for Janet is reliable, as it lies within the readings of the scatter graph. Her father's estimate is not reliable, as it lies out with the readings. Question 20, it says the diagrams below show a square and an isosceles triangle. So you've got a square which sides are all equal, and an isosceles triangle where the two sides are equal and one side isn't. So they have the same perimeter. By forming and solving the equation, work out the perimeter. So if we look at it, this one here, it says 4c is equal to 2c plus 11. The 4c comes from the perimeter of the square, which is c plus c plus c plus c. So 4 lots of c. And this one here is for the triangle. 2c plus 11 is the perimeter of the triangle. So c plus 3 plus 5 plus c plus 3. So that's c, 2c plus 3, 6, and 5 is 11. So we've got 4c equals 2c. It's equal because in the question it says they have the same perimeter, so they're equal to one another. What we now need to do is to kind of work out what c is. So this is just a normal solving equation. You can see they've got c on both sides here. So what I want to do is take away 2c from both sides, so we get rid of this one here. So when we take away 2c from both sides, that's 4c, take away 2c is 2c. And we're left with 11 here. We divide by 2 on both sides, so that means we're left with c on this side and 11 divided by 2, which is 5.5. So the next part of it says, work out the perimeter. So when we work out the perimeter, it should be 22. So even if we just take the square, that would be 5.5 on each side. So 5.5 on each side of this square. So when you add 5.5 all up on this one, it should equal 22. So that's why the answer is 22 there, the perimeter. Question 21, it says, calculate the surface area of a sphere with a diameter of 12 centimetres. So you need to know the formula for this, which is 4 pi r squared, or 4 times pi times radius squared. With this one here, just remember it's radius, because some people have the problem of just throwing 12 into here. Remember, diameter is 12, so we have to half the diameter to get the radius. So it's 4 times pi times 6 squared. And when we key that in, this is the number we get for the surface area of a sphere. So it's 452.389 centimetres squared. So remember, 4 pi r squared would be in your formula sheet in your GCSE. So for question 22, it says, calculate the size of the largest angle in the rhombus. Now in the question, it just had this rhombus like this here. So what I've done is I've split that into 4 little triangles. So now we've got a right angle triangle. Here, so it's asking you for the size of the largest angle. So remember, these side bits here will be the largest angle. So what we do is we just isolate one of the right angle triangles. So this one here is what I'm going to isolate here, so we can see it. I've drew it here. So we've got 15 and 8. Now we need the angle here. So because it's a right angle triangle and it deals with angles, we need to use trigonometry for this. So we've got tan is going to be the opposite. So 15 is the opposite and 8 is the adjacent. And all we do is we just substitute that in. So the opposite would be on top of the fraction, the 8 would be in the bottom of the fraction. And to find out the angle, we inverse the tan, we bring the tan across and we inverse it. We key that into the calculator and we should get 61.9275. Now that's the angle, the small angle in this little right angle triangle. But to get the largest angle in the rhombus, we have to multiply it by 2, so we can get both of those angles on the side. So that would be 123.855. And that's what I've got as the angle for the rhombus.